Welcome back to another video. In this tutorial, we are going to dive into the concept of cross or vector product. Cross or vector product. Okay, so basically, when we talk about the vector product, okay, of the vectors A and B, then uh, we can say that this vector product of A and B, okay, is given by is given by is given by A cross B, okay, is given by or is given as A cross B, and its magnitude, okay, its magnitude, okay, its magnitude is equal to the magnitude of A times the magnitude of B sine theta. So A and B, okay, is a vector product, and its magnitude, that is A cross B, the magnitude of A cross B is equal to the magnitude of A times the magnitude of B sine theta. So look at this in the dot product. You see, in the dot product, it's cos theta, all because we were dealing with dot product. Okay, and this is vector product or cross product. So in this instance, that is when you use the sine theta. So note the difference. The sine theta, the angle between them is sine theta when we talk about vector product or cross product. The angle between them is sine theta. But when we talk about dot product, the angle between them is cos theta. Okay. Now, these are measured from A to B. Okay. They are measured from A to B. So if A is equal to B, or if A is a magnitude, if A is a magnitude, or if A is parallel, if A is parallel to B, then we can say that sine theta will be equal to 0. If A equals to B, or if A is parallel to B, then we can say that sine theta over here will be equal to 0. Okay, and we define that to be A cross B to be equal to 0. Okay, so that is if A equals B, or if A is parallel to B, then the angle sine theta, okay, the angle between them will be equal to 0. And over here, okay, so that is basically all about the vector product. Now we have to take note of these key metrics, or these key properties. Okay, in vector product, you are going to deal with matrices. Okay, so order is very, very important. Order is very, very important. Order matters. So, Fred Carl Gosh, okay, the man of matrix, he really appreciates order. So, if the moment you are heading towards matrices, you have to begin to respect order. You don't just mess things up. Once you change the order of one argument to the other, you begin to get different results. So in vector product or cross product, order is very, very important. Order is very, very important. So let's say that you have A cross B, okay? A cross B. This A cross B is equal to negative B cross A. That is the first property. The second property is, so you see this, A cross B equals negative B cross A. You have to respect the order, okay? maintain the order, because for instance, if B is a matrix, okay, and A is also a matrix, and you want to have the cross product of these two elements, then you have to really appreciate order, because once you change the position of A and the position of B, you're going to have a different result altogether. So let's take note of that. Okay, so the B is, if you have A cross B and multiplication. So if you have A cross B plus C, then applying the distributive property, you can say that you have A cross B plus A cross C, right? So that is basically the use of the distributive property over here. Okay. The third property is, for instance, you have M multiplied by AB. Okay, the distributive property. So you can see that this is, the M is basically a scalar. Okay, so when you multiply a scalar by a cross product, it's the same as multiplying the scalar by the vector. Okay, multiplying the scalar by the vector times the vector, or multiplying the vector by scalar and the vector, or multiplying the vectors times a scalar. They are all the same. Basically, when it comes to vector product, I dot I cross I is equal to J cross J, and that is equal to K cross K. And in vector product, that is equal to 0. But when you go to unit vectors, okay, this one is equal to 1. Okay, when you go to unit vectors, this is equal to 1. But in vector product, this is 0. So take note of that. And when you come here, I cross J is equal to K, and also J cross I is equal to negative K. Okay, the same thing applies to J cross K equals I, and K cross J is equal to negative I. Basically, that it follows in that order. Okay, so let's look at the last property, which is the last. A equals A1I plus A2J plus A3K, okay? And B equals B1I plus B2J plus B3K, okay? Then if you take A cross B, then you're going to have the magnitude of A cross B is the same as the area of parallelogram. The magnitude of A cross B is the same as the area of a parallelogram. Okay, so you have A cross B, that is the magnitude, okay, is equal to the area of a parallelogram. Okay, so that is equal to IJK, okay, and the elements are A1, A2, A3, and B1, B2, B3. So if you take the magnitude of these position vectors, two position vectors, then you are going to have the area of a parallelogram. But if you want to know the area of a triangle, then it's going to be half of the magnitude of A and B. Okay, so that's the area of a parallelogram is equal to A cross B, the magnitude of A cross B, okay? And that of the area of a triangle, the area of a triangle, the area of a triangle is equal to, triangle is, if you want to find the area of a triangle, it's basically half of certain quantities, right? So over here, you're going to have half of the area of the parallelogram, and that becomes the area of the triangle. So that is half of the magnitude of A cross B becomes the area of a triangle. So note the difference. If you have two position vectors, okay, that is position vector A and B, and you find the magnitude of this uh, position vectors, that is A cross B, the magnitude of A cross B, then you have the area of a parallelogram. Once you get the area of a parallelogram, then half of the result will be the area of a triangle. Okay, so that is basically the fifth property. Note this very well. A cross B is perpendicular to A and B. That happens, okay? A cross B is perpendicular to A and B. A cross B is perpendicular to A and B, meaning the angle between them is 90 degrees. The angle between them is 90 degrees. So A cross B is perpendicular to A and B. Wow. The properties, property 1 to property 7, let's have those properties at our fingertips. Now let's take this practical example to clarify the concept. Okay, so problem 1, we want to show that A cross J is equal to K. Okay, so now that was a property 7, right? Property 6. Was it property 6? Okay, property 6. Now we want to prove that A I cross J is equal to K. So solution. Let's assume that A is equal to 1, 0, 0. Okay, and B is equal to 0, 1, 0. Okay, so in order for us to prove that, this is equal to this, then we are representing vector A to be 1, 0, 0 and vector B to be 0, 1, 0. Okay, so you know that if you want to take the cross product of these two these two vectors, then it's going to be A cross B equals, the moment you talk about cross product, begin to think about matrices. Okay, so A cross B will be equal to 1, 0, 0. Okay, so the first row becomes your position vectors, right? I, J, and K. Okay, so the first element under the I is 1. The second element, so in that order, 0, 1, 0. Okay, so now let's find the determinant of this. So the determinant of A cross B will be equal to 1 I into 0, 1, 0, 0 minus J into 1, 0, 0, 0 plus K into 1, 0, 0, 1. Okay, so basically we are trying to prove that I cross J is equal to K. Okay, so we have A cross B to be equal to I into 0 times 0, that is 0, minus 1 times 0 is 0, minus J into 0 times 1 is 0, and 0 times 0 is also 0. Okay, then plus K into 1 times 1 is 1, minus 0 times 0 is 0. Okay, so we have A cross B to be equal to I into 0 minus 0 is 0. So 0 times I is 0. So we have this part to be 0 minus 0 minus 0 is 0 times 0. J becomes 0. And k plus k into 1 minus 0 is 1. So 1 times k becomes k. So therefore, A cross B equals to k. So that is I cross J. So basically, let's use I and J, okay? Because we are trying to prove that um, I cross J is equal to k, okay? So this is supposed to be I cross J. Our representation is I cross J, okay? So that is I cross J is equal to k, hence hence proved, hence proved. So that is the process. If you want to prove that a cross I cross j is equal to k, represent I by some vector um, element, right? Some vector. Okay, so you know that the magnitude of I is 1. So the rest will be 0 because we don't know about them. Then J, the position side of J will be 1. Then the rest will be 0. Then you present it in a matrix. That is the process. You know how to find determinants, then you are good to go. In vector product, it's all about finding determinants and stuff, okay? So that is problem 1. Let's go with problem 2. We have been given two position vectors, okay? And we are to determine A cross B and find the area of a parallelogram with sides A and B. Okay, so this is too easy, right? You can do it. Please, you can pause the video, try it, and come back, check. Okay, so solution. The first part of the question, A cross B is equal to, we have two position vectors, that is A and B. So A cross B will be basically, the first row will be the position vectors, okay? Then the elements follows, okay? 7, 11, and 9. Okay, so we want to find A cross B. So basically, it's all about matrices, okay? Determinants. So A cross B is equal to I into -6, -11, 4, 9, minus J into 8, 7, 4, 9, plus K into 8, 7, -6, and -11. Okay, so this is what we have from the breakdown. Okay, so we're going to have A cross B to be equal to I into -6 times 9. So you have to multiply that 6 times 9, and that is 54. So we have -54, right? Then 4 times 11, okay, that is 44, but it's negative, so we have -44, okay? And on the off diagonal, we have a negative sign, so that is going to be plus 44, right? Minus J into 8, 9, right? That is 72, right? So we have 72 minus 7, 4, 28. So we have minus 28, right? Then plus K into um, 8 by 11 is negative. We have negative with the negative, the 11. So it's going to be negative 88, right? Minus 7 by 6 becomes 48, right? 7 by 6, that is 42. So we have -42, but on the off diagonal is negative, so that becomes plus 42. Okay, so A cross B will be equal to I into negative 54 plus I into minus 54 plus 44 becomes minus 10, right? Minus J into 72 minus 28 is basically 44, right? So we have 44 here plus K into um, minus 88 plus 42 is minus 46, right? So we have our A cross B to be equal to negative 10I, negative 44J, negative 46K. So that is the position vector for A cross B. Okay, so once we have A cross B, then we can go ahead and find the magnitude of A cross B, and the result we obtain becomes the area of the parallelogram with sides A and B. Okay, so the area of a parallelogram, the area of a parallelogram with sides A and B is given as square root of negative 10 squared plus negative 44 squared plus negative 46 squared, right? So basically, that is going to be negative 10 squared is 100 plus negative 44 squared is 1936 plus negative 46 squared is 2116, right? So when you break this down, square root of 100 plus 1936 plus 2116, you're going to have 64.436. So this result we have here, okay, this result we have here becomes the area of the parallelogram. So that is 64 squared units, because certainly you have a particular unit for every quantity, right? But over here, we don't know the actual unit. So we say we have a square unit. So whatever unit is going to be, then we add it up. So, area is squared, right? So the area of this parallelogram with sides A and B is 64.436 square units. So let's look at the last example under vector product. Okay, so problem 3 is we are to find the area of a particular triangle with sides A to be 2, negative 3, and 1, and B to be 1, negative 1, and 2, and also C to be negative 1, 2, and 3. So once we hear area of a triangle, we have to dive into area of a triangle, right? So we know that area of a triangle with sides A, B, and C will be equal to half times the magnitude of position vector AB cross cross times the magnitude of position vector AC. So because we have three sides, we have to take the position of vector of AB and find the position vector of AC. Then we find the cross of these two. Once we get the cross of these two, then we find the magnitude of that and take half of it. Then the result becomes the area of the triangle. Okay, so we're going to have position vector AB is equal to B minus A, right? So that will be equal to 1, 1, 2 minus 2 neg 3 1. Okay, so that is equal to 1 minus 2 becomes negative 1. Negative 1 minus minus 3 becomes plus 2, right? And 2 minus 1 becomes plus 1, right? So we have the position vector for AB. So position vector for AB is equal to negative I plus 2j plus k, right? And position vector for AC will be equal to C minus A, right? So we have our C here to be negative 1, 2, 3 minus 2 neg 3 1, right? We have that. We find the determinant, and that is going to be I into 2, 5, 1, 2 minus j into neg 1 neg 3 1, 2 plus k into neg 1 neg 3 and 2 and 5, right? So this, we are going to have A, B, position vector AB cross position vector AC will be equal to 4 by 2, 2 by 2 before. So we have I into 4 minus 5, right? Then minus j into neg 1 by 2 is neg 2 plus 3 plus k into neg 5 plus 6, right? So that is going to be 4 minus 5 becomes negative 1. So we have negative I, then neg 2 plus 3 becomes plus 1. So we have negative j plus k into negative 5 plus 6 becomes plus 1, right? So that is going to be plus k. And that is what we have here. So we have position vector AB cross position vector AC to be negative I, negative j plus k. Okay. Now we have this. We have to find the magnitude of this. Then when we are done, we find the half of the result, and that becomes the area of the triangle. Okay, so the magnitude of AB, position vector AB times position vector AC will be equal to square root of negative 1 squared plus negative 1 squared plus a positive 1 squared, right? So that is basically 1 plus 1 plus 1. So that is square root of 3. Okay, so we have the position vector AB cross position vector AC, their magnitude to be square root of 3. So once we have this, the only thing we have to do is to take half of this result, and that becomes the area of the triangle. Okay, so that's the area of triangle A, B, and C, triangle with sides A, B, and C is equal to square root of 3 over 2, because you take half of this result and that becomes the area of the triangle. So square root of 3 over 2 squared units. Square root of 3 over 2 squared units. And that is the area of the triangle with sides A, B, and C, respectively. Ladies and gentlemen, that is the process that we go through to find the area of a triangle, to find the area of a parallelogram, and to find the area of a parallelepiped. That is so interesting. So please don't forget to subscribe, share with your mates, and I'll give you more updates. Bye-bye.